Joshua once again. This time we are going to discuss the effect of heat during the change of state. The effect of heat during the change of state. We can study the effect of heat by carrying out an experiment to determine the melting point of naphthalene. And this one, we set up our apparatuses. We get the boiling tube, we have fill it with naphthalene, and then we dip in the thermometer. Then we put the whole setup of the boiling tube, naphthalene, and the thermometer. We clamp it on the retort stand, and then we place the whole setup of the boiling tube into the beaker with cold water. When we have finished the setup, naphthalene in the boiling tube, thermometer in the boiling tube in the beaker with cold water, then we provide the heat source. We start heating the water in the beaker. But before we start boiling the water in the beaker or provide heat to the water in the beaker, we first of all note the temperature of naphthalene. Then we start providing heat. When we provide heat, the heat is going to raise the temperature of the water in the beaker, and when the water in the beaker temperature rise, they will provide or distribute heat to the naphthalene in the boiling tube, and it will be provided evenly. We are using water, not heating the electrolyte, the naphthalene in the boiling tube, because we want the water to distribute the heat evenly to all the naphthalene. Now, when we start heating, every 30 seconds, we note the temperature reading in the naphthalene. Time is going to come when naphthalene starts to change from the solid state to the liquid state. We stir the naphthalene to get a constant temperature. We are recording the temperature changes every 30 seconds. And when we get that constant temperature, that one is the melting point of naphthalene, until when all the naphthalene has changed into the liquid. When all naphthalene changes to the liquid, we remove the heat source, or we remove the boiling tube from the beaker. And when we do that, the boiling tube will start to cool down. And as it is cooling down, the liquid naphthalene will start changing from liquid and going back to the solid state, which we refer to as the freezing process. And the temperature will remain constant from the time it changes from liquid until all of it changes to solid. The temperature will remain constant, and when now it starts cooling down, it will be in a solid state. Now, all that process can be represented on the graph. We shall have our x-axis, which will represent the change in time in seconds, and then the y-axis, which is going to represent the change in temperature. So from point A, that is when we note the temperature of naphthalene at point A. Before we start heating, that one we are giving it temperature A. Then as we keep on plotting, we shall reach a point which is point B, when naphthalene starts melting. At that point B, the temperature is now going to become constant up to point C. That is when the solid naphthalene is changing to liquid naphthalene. And when all the solid naphthalene has changed to liquid naphthalene, then the temperature will start rising from point C to point D. That is now the liquid part, which is trying to increase in temperature. Now when you observe these areas, from point A to point B, there is rise in temperature, and in that phase we have only solid naphthalene. We shall call that phase X. Then from point B to point C, that phase, we shall call it the Y phase. In the Y phase, we have both the liquid naphthalene and solid naphthalene. Then we shall have from point C to point D, that one we shall call it the Z point. And in the Z point, we have only the liquid naphthalene. That is when we are boiling. That is our heating curve. Now the cooling curve will be the opposite. It starts from up when we have the temperature of the liquid which is high, and when we cool the temperature or we cool the liquid, the temperature cools to point C, whereby from point C the temperature now becomes constant to point B, and when we reach point B, then the temperature now again reduces to point A. From point D to point C, that phase there we have only liquid naphthalene, and the liquid naphthalene is cooling. When it reaches point C, the temperature becomes constant to point B. In that phase, we have both the liquid naphthalene and the solid naphthalene. That is when the temperature is constant, or what now we are referring to as the freezing point of naphthalene. Then from point B to point C, that is the phase where we have only the solid naphthalene, and that one is now naphthalene cooling down. That is the effect of temperature during the change of state. Thank you for staying with us. Continue to be with us as we continue to simplify chemistry. God bless you. Hello, my name is Joshua. Thank you for staying with us. Continue to be with us. Thank you, and God bless you.